This lesson will teach me to graph a quadratic function, extract information about a quadratic function when given its equation or graph. The majority or the beginning of this lesson is a refresher from the first half of the quadratic unit. Standard form of a quadratic equation is any equation in the form y equals a x squared plus bx plus c. Parabola is the U-shaped graph shown over here. Axis of symmetry is the vertical line. So it's this vertical line right here that is dividing the parabola into two equal halves. Its equation is x equals the opposite of b over 2a, b and a. Vertex is referred to as the highest or the lowest point of the parabola, also known as the minimum or maximum, and it's always written as an ordered pair. Here, this vertex is a minimum because it's the lowest point. The x-intercepts are where the graph touches the x-axis. They are known as roots of the equations, zeros of the equations, or solutions. And then y-intercept, where it's crossing the y-axis. Domain and range. Domain are all of the x values that make an equation true, and range are all of the y values. The domain for any quadratic function is from negative infinity to infinity. And this is because we can put in any value along the x-axis to make this equation true. However, for range, it's going to depend on the vertex. Whenever we write domain and range, we have a tendency of using interval notation. When we use interval notation, we start from the lowest point and we go to the highest. So if you look at a graph that's downward facing, meaning one that has a maximum, and we look at the range, we're asking how low is the low, how high is the high. Well, given that these have arrows, the lowest value is negative infinity. So we walk along this curve and you look at this curve and its lowest is negative infinity. What's the highest the y value will be? Well, it's right up here. The highest this particular graph will be is -1. It touches it. So it's not the open parenthesis as in less than or greater than. It's the closed parenthesis because it has that or equal to. Let's try this other one over here. When we have a vertex that is a minimum, let's see if I can scroll down a little bit. We have a vertex that is a minimum, meaning that we have an upward facing graph. You look at the lowest of the low of this curve and it's this point right here. This lowest value lines up to y being 1. It's touching y equals 1. There's a dot there. It's coming down and touching it and then bouncing back up. So we have this square bracket for or equal to, comma, what's the highest of the high? Well, it's going to be infinity and never reached. So when the graph opens upward, meaning you have a minimum as your vertex, lowest value to the highest value. When you have a downward facing with a max as the vertex, the lowest is going to be negative infinity with the arrows, and the highest is going to be the y value of the vertex. Parts of a quadratic function. The quadratic function is anything in the form of y equals ax squared plus bx plus c. The a affects the direction. A positive a value opens upward, a negative a value opens downward. The actual number of the a value, think of it more as an absolute value, affects the width. The whole number, or the larger the whole number, the skinnier the u. So if you were to take a u-shaped graph, the standard width is of the parent function y equals x squared. This is as basic as it gets, thinking about this as a 1. So this has a standard width. As you increase this number and make this one larger and larger, and you make it a 2 or a 3 or a 4 or a 5, as that number gets higher and higher and higher and higher, it's pulling this U shape skinnier and skinnier and skinnier each and every time. If you were to take that standard equation, y equals 1x squared, and start making this into a fraction, the lower the number you create, and I'm not saying negative, I'm saying the smaller the number you create, that standard graph is getting pushed outward and is getting fatter and fatter and fatter. So if you were to look at an equation, for instance, y equals negative 2x squared, well, the negative represents that it's downwards. The 2 represents that it's skinnier than standard. If you were to look at y equals positive 2x squared, we don't always write the positive, but the positive that we say or we think means it's opening upward, and the 2 represents that it's skinnier than standard. The center B value term, and this is what kind of makes things a pain in the butt. What this term does is it's not exactly the axis of symmetry, but it affects the movement of the axis of symmetry. And specifically, it moves it left or right. If you had an equation without an axis of symmetry, so if you had, or I'm sorry, they all have an axis of symmetry. If you have an equation with no bx term, y squared, gosh darn it, I'll get it, y equals x squared plus 9. The fact that there is no bx term means that the axis of symmetry is at 0. The presence of the axis of symmetry just means that the presence of the b value just means that the axis of symmetry is not at 0. And then lastly, the c value is your y-intercept. Moving on. Steps to graphing a quadratic equation. These are not new. We find the axis of symmetry by using negative b over 2a. The number that you calculate goes in the x part of the box. Then since you have the x value, we can plug it in to get the y, and we can further populate the table from there. When we graph all the points with a smooth curve. These graphs don't shoot straight up because that's not a function, so you got to do your best to kind of give them a little curve. All right, so let's get graphing. I'm going to do the first one. You're going to finish the second one on your own. So for the first one, I'm going to identify my a, b's, and c's. A is equal to negative 8. B is equal to 0 because it's not present. And C is equal to 2. Remembering that B term has the x with it. So if I were to do x equals the opposite of B all over 2 times A, 0 divided by negative 16 is 0. The fact that there is no bx term in this equation automatically means that the axis of symmetry is 0, meaning that this parabola is going to fold over the line or over the y-axis. Things that are larger than 0, things that are smaller than 0. Grabbing your calculator and you can plug these in. When you're using your calculator, keep in mind that we do need to wrap the value that is being plugged in for the x in parentheses. I know that there are no parentheses given, but if you notice it does say x squared. If you were to type negative 2 squared, your calculator is only squaring the 2 and then bringing along the negative. If I want to do x squared, then truly we need x times x, which means negative 2 times negative 2. So to get your calculator to do that, we wrap it up. For sake of speed, I already have these calculated. So I got negative 30, I got negative 6, 2, negative 6, and negative 30. So now when I go to graph this, at negative 2, I'm at negative 30. There's no way I'm going to get that to fit, but I can get negative 1 and negative 6 to fit. Negative 1, 1, 2, 3, 4, 5, 6, 0, 2, and 1, negative 6. So it's going to be really skinny, and I'm going to do the best I can to draw this on my tablet. Oops, sorry, that's not the greatest. Hopefully you get the idea, but it's going to be really skinny. The negative means that it's opening downward. The 8 means that it's a large number, which means that it's very skinny. So the axis of symmetry we calculated at x equals 0. Axis of symmetry will always be x equals a number. The vertex is the ordered pair, and we calculated our vertex at 0, 2. Is the graph opening upward or downward? Well, we can see that it's opening downward, and we know it is because of the negative in the equation. Is there a maximum or a minimum for the vertex? Well, there's a maximum. Roots. There are two roots. We can't really identify them clearly here. I mean, not only is my graph less than perfect, but we would need a graphing calculator because they don't cross nicely. The domain for any quadratic is negative infinity to infinity. Given the fact that this graph has a maximum, and we go to list the range, the smallest value is negative infinity, and it's going up to its maximum point, which we have calculated as 2. Graph B, you do on your own. Turning the page. So I'm going to start here with this middle one. You are going to do all of this, and you are going to do all of that. Don't write you do, like you actually do the problem, please. Anyway, so what I'm going to list here, let me get a different color. My A value is a -4, my B value isn't there, and my C value is 3. So if I'm asking you to calculate the axis of symmetry, it's always x equals the opposite of b over 2a. Well, since my b value isn't there, 2 times -4 is -8, my axis of symmetry is at 0. Give yourself a little sketch if you want to. I know it says without graphing, but that doesn't mean that you can't help yourself out here. So x equals 0, meaning this thing is being folded here. The vertex. If you have the axis of symmetry, the vertex is going to be somewhere on the axis of symmetry, so I'm going to plug it in. Y equals -4, 0 squared plus 3. This is going to equal 3, meaning the vertex is 0, 3. So 1, 2, 3 right here. Is it a max or a min? Ask yourself, is it opening upward or downward? Because that A value is a -4, that means this is going to be opening downward. So this graph is going to be a maximum. So if you kind of want to add to your sketch, again, not beautiful, domain is always negative infinity to infinity. The range, because of that maximum point, its lowest value is negative infinity. It's going up to its highest point, which is its vertex, stopping. The number of roots that it has, well, based on my sketch, roots are the same as solutions. It has 2. It's not asking you to identify what they are, just how many it will have. So you're completing A, you're completing C, and I guess you're completing over here. You're going to, so down here where you're completing the idea of quadratic functions going from the widest to the narrowest, what you're looking at is, you are looking at the A value. So for the widest, you're looking for a fraction. Narrowest is that whole number. And you're ignoring the sign. What the sign does, the positive or the negative, affects the direction. You're just looking at the A value. It's the A value that's affecting the width. So go ahead, you still need to order these functions from widest to narrowest, and you can just list ABC or CBA or BA, whatever the order will be. So there you go. Thank you so much.